Hey, everyone, Mr. K here with another video, this time talking about Chapter 5, Functions. So today we're going to talk about what functions are. We're going to talk about calling functions and writing your own functions. We'll also talk about what local variables are. We'll also talk about passing arguments to functions. Later on, we'll talk about global variables and global constants, value returning functions, writing your own value returning functions, and the math module, and using modules. Now, you may ask yourself, why use functions in the first place? Or for that matter, what is a function? Well, one definition is a function is a group of statements within a program that perform a specific task. Usually one task of a large program. And then you can execute them in order to accomplish the overall task. This is known as divide and conquer. And this is actually how a lot of software is written. You have a huge piece of software, like say Microsoft Word, and it's broken down into small pieces that individual programmers work on, and then their work is combined together to make the overall piece of software. We call this kind of software that's broken into pieces using functions a modularized program. That is, a program wherein each task within the program is in its own function. Let's look at how that works. Now, up till now, we've had programs that are just one statement after another statement after another statement, etc. With modularized programs, that is, programs that use functions, we break the statements up into groups, and we call each one of those groups a function. And that function may do a set of related tasks like add, multiply, divide, what have you. We'll see examples in just a little bit. Matter of fact, why don't we just go ahead and skip ahead and look at a rather simple example. Here's a program with one simple little function, and here's the syntax of it. You have the keyword def that says, hey, this is the start of my function, the name of the function itself, in this case message, the parentheses, which we can use to pass optional information to the function, and then the colon, which is the start of the function. Notice that the code underneath must be indented. Okay? So what does this program do? It prints out, I am Arthur, King of the Britons. Now, by itself, the function doesn't do anything. In order to use the function, you've got to call the function. And that's what we do down here. So notice where it calls the function, that's not indented. Let's put a breakpoint there. Let's go ahead and hit debug. Okay, so our line is here showing this is where we're at. And I'm going to move my mouse up here to step into, and I'll zoom in down here a little bit on my output window. That's a little easier to see. And we'll go ahead and we'll step. And notice it goes into the function, it goes past the header of the function, and it prints out, I am Arthur, King of the Britons. And when it's done, it goes back to the caller. Maybe we missed that part. Let me make that a little easier to understand. I'll say print, welcome to my program. And then afterwards, I'll say print, thank you for using my program, just like that. Okay, great. So once again, I'll hit debug, and we come to that line. I hit step into. We use the print function to say, I'm Arthur, King of the Britons. And then afterwards, it goes back to the caller and says, thank you for using my program. Okay, continuing on. So, why would you want to use functions? Well, several reasons. The code is simpler because you can break it into smaller pieces. Also, when you modularize code, you're more easily able to reuse the code. That is, write the code once and call it multiple times. Not really something that's a big issue or can be foreseeable as an intro to programming student, but redundancy is the enemy of efficiency. Redundancy is the enemy of efficiency. It also makes it easier to test and debug because you can debug and test each function individually. You can develop work faster because you can break it into pieces and assign the pieces to different people, and that is also enables facilitation of teamwork, so different team members can write different functions. Two general categories of functions. Void functions return nothing. They simply execute the statements they contain, and then they terminate. This is an example of a void function. Okay? It just does its job, and then goes back to the caller. The other type of function is a value returning function. It executes the statement it contains, and then it returns a value back to the statement that called it. Okay? For example, input. We've been using input since our first Python programs. When we call input, we typically print a message to the user, and then we get a string back. That string that we get back is the value that's returned. The int function, when we convert a string to an integer or a float to an integer. A float, we convert from a string to a float. Those are all examples of value returning functions. So, in order to use a function, you've got to give a function a name. And there's some rules for naming functions. For example, you cannot use keywords as a function name. You can't call your function def, you can't call your function if, you can't call your function return, etc. Also, you can't have spaces in your function name. But remember Mr. K's rule about using camel case? No, you need to use spaces then. The first character in function names must be a letter or an underscore. It's usually a letter. And all the other letters must be a letter, a number, or an underscore. So notice that it could be, they can have letters, numbers, and underscores, but they have to start with a letter or underscore. And that it matters if you use upper or lowercase letters. They are distinct. That is, it is case sensitive. Okay, so when we name our function, we want to give it a name that describes what the function does. We want to always use meaningful names when we write our software. We've seen this with variables. Now it's time to use this with functions, okay? Could you imagine the print function being called something like my function? That wouldn't be particularly useful. One way to think about how to write software is, and I'll just open up Notepad++ over here so I can jot this down for you. And let me just bring this over here to this screen, and I'll open up a new window. And I'll think of this, and we'll think of variables as being the nouns in a program. That describes objects, things, etc. And then functions are the verbs. They do stuff. Okay, and that's what functions do. They do stuff. All right. Whoops, wrong screen. I'm sorry. So, to write a function, I use the keyword def, whatever I want to call my function, the parentheses, the colon, and then whatever I want my function to do. Notice that the statements must be indented, and they must be indented consistently. So we call that first line of a function the function header. That's the part that has the def, the function name, the parentheses, and the colon. And then the code that follows is a block, that is, a set of statements that belong together in a group, like we saw in our example here. Okay, this would be an example of a block. So in order to use a function, I've got to call it. If I didn't have this line here, line number 9, and I'm just going to highlight that, and I'm going to comment out that line. So notice now it's commented out. If I run this program, notice it does not print out, I am Otho, King of the Britons. You need to call the function in order to execute it. And when you call a function, execution jumps to the function, executes the statements in that function, and then goes back to where that function was called and continues. That's known as the function return. Now later on we'll talk about return statements, but once again, just if you missed it, I'll show you. There's our breakpoint. Oh, notice how we don't hit our breakpoint because it's commented out. Let's clear this over here. And let's hit debug again after I uncomment. There we are. Okay, so we get to our call to the function. We step into our function. The function does its job, and then it goes back to where it was after the call to the function and continues. All right. So there's a special function in Python programs, and every Python program should have one, although not every Python program does, and that function is called main. Main is the function where execution is intended to begin. The purpose of main, and there's several beyond what we see here, but we'll get to that as we progress. The purpose of main is it is the start of your program, and it calls other functions when they're needed, and also defines the mainline logic of the program. Now, we've already seen two functions.py. I'm sorry, we've already seen function demo.py. Let's take a look at two functions.py. All right, so here's two functions.py, and notice we have two functions. As mentioned just previously, we have that function called main, and it says, I have a message for you. And notice that main then calls the message function and then prints goodbye. And the message once again prints, I am Arthur, King of the Britons. So our program starts with a call to main. So let's clear this. Let's put a breakpoint here. Let's hit debug. And let's step into, and notice we go to main, okay? And then main prints out the message, I have a message for you. Calls message, where it jumps the message, prints, I am Arthur, King of the Britons. And when it's done, it goes back to where it was in main, prints goodbye, and then it would continue on from our call to main. Two important points, okay? One, it doesn't matter. It doesn't matter if main is the first function, the last function, or any function in between. Let me just rearrange this ever so slightly. So now main is the second function, and I'll clear this, and I'll just run this, and notice the output is just the same. But also notice that if I don't call main, and I try to run my program, nothing happens, okay? In order for a method to do anything, for a function to do anything, it's got to be called. So just because we wrote main doesn't do anything. If you know a little Java, it's unlike Java in that regard. You've got to actually call main in order for main to work. So we'll put the main back in, we'll run that, and there we go. Indentation. One of the things about Python that makes it somewhat unique is that indentation matters. In a function, each block must be indented, and it must have each line indented with the same number of spaces. Now you could use tabs or you could use spaces, okay? But don't use both. Either stick with tabs or stick with spaces. This example here, notice it uses tabs, okay? And tabs, they're a little easier, you know? So just press the button and that's it. You could always still use spaces, but that makes your program slightly larger. One of the neat things about idle, and PyScripter for that matter, is if you start to write a block, it automatically indents it for you. So if I start to write my own function, and let's do that just for fun. We'll say def my function colon and enter. Notice the cursor goes automatically to the next line where it's indented. And I could say print this is my function, just like that. If you have blank lines in a block, they're ignored. So let's just go ahead and put that in there. If I have a blank line between I am Arthur, King of the Britons, and I run my program, notice it just completely skips over the blank line. It doesn't make a difference. But please don't have blank lines except before comment lines. Makes things a lot easier to read. I think that's in Mr. K's coding rules. Okay, here's an exercise for you, and the exercise is the following. Write a Python program that has a function called first name that prints your first name, a function called last name that prints your last name, a main function that prints hello world, calls first name, calls last name, and then prints goodbye. So pause the recording here and hit resume when you think you've got it. Okay, did you get it? Gosh, I hope so. Let's have a look at how I solved it. So I put a title block on my program with my name and last revised date and a description, etc. And let's just walk through the code quickly. As the code says, it has a first name function. Okay. Oh, and I did this a little bit wrong. Let me fix this for you here. And I'll say my first name is Charles, and my last name is Wiatkowski. Okay. And then down in main, I print hello, I call first name, I call last name, and then I print goodbye. So let's put a breakpoint here. Oh, and notice I also call main at the end of my program. So I'll put a breakpoint there, and we'll just step through quickly. Okay, so there's my call to main. I'll step in, and notice it prints hello world, calls first name, which prints my first name. Then it goes back to main, where it calls last name. Oops, and what does it not like about last name? Oh, my mistake. Okay, let's clean that up. Let's fix that. Let's clear all this garbage. I forgot to take that out of there. I apologize. Let's try this one more time. Okay. So there's our call to main. So we'll step in to main. We print hello world. We call first name, that prints my first name is Charles, goes back to main, calls last name, prints my last name is Wiatkowski, and then prints goodbye. It's just that simple. All right. Now, you may have heard me say before that code is communication. It's communication not just to the computer, but also to other programmers. Okay? And one of the ways to describe what code is doing is through the use of what's known as a flowchart. And we've seen flowcharts a little bit, and I think we talked about the different symbols. In a flowchart, if I have a part of the program that calls a function, the way that I do that is with a rectangle, okay, and it's usually a rectangle with the sides on it. And then inside of the rectangle, I show the name of the function that I'm calling. So for our first example, we would output to the user, and there's our parallelogram for input-output. Display I have a message for you, call the message function using that rectangle, and then display goodbye. One way to create software is through the use of what's called top-down design. That is, breaking an algorithm down into functions, okay, so that you can work on the individual pieces to make them a little bit easier to digest. So when I'm working with functions, sometimes I like to describe the overall structure of a program using what's known as a hierarchy chart. That is a structure chart. Each function has a box, okay, and then you have lines connecting the box that illustrate the functions called by each function. However, a hierarchy chart doesn't show what goes on inside of the function. That's kind of the role of a flow chart. This just shows what functions are called by what other functions. So, for example, use the input function to have the user wait for the user to press enter. So here we have this hierarchy chart for this program. And which program is that? Let's see here. Let's see. Is it birds? Change me? Commission rate? No, I don't think so. I don't know if that's any of those. No, it's not. Okay. But you see the main function would first call get input, which calls two other functions, get hours worked and get hourly rate in that order from left to right. Then main would call get calc gross pay, calc overtime, calculate withholdings, which calls get calc taxes and calc benefits, and then it calls calc net pay. If we look at that, let's look at Acme Dryer.py. So here's Acme Dryer.py, and I will just close this window, make it a little easier to see. And we see from the description at the top, this program displays a step-by-step set of instructions for assembling an Acme dryer. The main function performs the program's main logic. So it calls this function called startup message, and I'm going to put a breakpoint here, and we'll just go ahead and walk through this program. So main calls startup message, and then startup message prints out. This program tells you how to disassemble an Acme laundry dryer. There are 4 steps in the process. Okay, so I step through, and then it goes back to main. It says press enter to see step 1. So we'll do that. And then in step 1, or I should say then it calls step 1, which prints unplug the dryer and move it away from the wall. When it's done, it goes back up to main. It says press enter to see step 2. So I'll do that. And then it calls step 2, which says remove the 6 screws from the back of the dryer. Then press enter to see step 3, and I'm just going to hit resume. Enter to see step 3. Step 3 says remove the back panel from the dryer, and then step 4 says pull the top of the dryer straight up. So we see we have those 4 functions. Okay, if we look at main, 1, 2, 3, 4. And we press enter in between each of those calls in order to print them out individually. So let's do this. Let's create a hierarchy chart for Acme Dryer. I'll go to draw.io, and we'll make a hierarchy chart. It's being a little slow here. And I'll just save this to my device. I'll create a new diagram. Let's see here. Was that a business diagram? Well, actually, if I just do a basic diagram, it doesn't really matter. So we'll call this Acme Dryer. Like that. And I'll click on Create. And notice on the left here, I've got these symbols. Okay. So with a hierarchy chart, remember, I've got the rectangles, and then the rectangles call the other rectangles. Now, they don't have arrows here, but I like to use arrows when I make a hierarchy chart. So I'd start off like this. I'll drag a rectangle from the left. I'll name it main, because that's my first function. And then when I press enter, it goes to create another one. Now, if I look at Acme Dryer, the first one it calls is startup message. So I will come over here and notice it moves the arrows accordingly, and I'll just call this one startup message, and then I'll press enter. There we are. Now, something about a hierarchy chart is the lines should always come from the bottom, not from the side. So I'll move my line there, and notice now it prints the startup message. If I look at startup message, you see startup message calls print, right? That's another function. So in my drawing, I'll put another rectangle. I'll call it print. And then I'll come over here, I'll take one of those directional connectors, I'll put one end at the bottom of startup message, the other end at the top of print, and there we go. After it calls main, the next method that it calls is called step 1. And if you remember, step 1 calls print. So let's put that in there. So let's draw, let's call that step 1, and we'll press enter. Oops. Step 1, and we'll connect it. Okay. Come over here, and we'll try not to cross the lines. Try to move these lines out of the way here. So they're nice orthogonal lines, that is, they are at 90-degree angles. So they look nice and neat. Okay. And there it calls step 1. Now you remember step 1 calls print as well. So let's represent that. And we can actually cheat a little bit. We could take this part, we can right click, we can copy, we can come over here, and we can paste it. Look at that. There's a call to print. Now remember, after we call step 1 in main, we call input, right? Press enter to see step 2. So I'll represent that. And I'll say input, like that. And I can take a directional connector and I can put it down there. And let's make this a little neater. Let's take that down there like that. There you go, and there's input. And I could go through from left to right, filling in all the functions that are called. Okay? We get the idea. When I go to save this, and if you ever go to do anything in draw.io, make sure you save your work, but don't save it as an XML, because that doesn't work. Okay? What you want to do is save it as, you probably want to do this on your Google Drive, but that's okay. Probably want to download it, okay, as an XML. And I'm just going to do that here in Chapter 5. Then if I click on the XML drawing, or click on the XML file, now see, here's the problem. If I go to open it with a browser, it looks like garbage, right? It can't do anything with that, just all that gibberish there. Instead, if you ever go to submit something with draw.io, because this is saved online, click File, Export as, JPEG, and then click Export, and I'll put this on my device, and I'll call this Acme Dryer. And now, notice it's a JPEG file, so if I open it up, there's my drawing. So don't save as an XML because that's not really viewable by somebody else. Make sure you save as a JPEG. That said, let's move on to the second exercise, and that is use draw.io to draw a structural diagram that is a hierarchy chart to represent the triangles program with functions. Now you might say to yourself, what's the triangles program? I'm glad you asked. If you look at Chapter 5, under Presentation Materials, there's an example called In-Class Triangles, and we could download that. Okay, so I'll just download that here, and then I'll open that up in PyScripter. There's in-class triangles, and you see this program will determine what kind of triangle we have. So there's a main function, there's an is-equilateral function, an is-right function, and then in main it gets the sides, it does input validation, it also calls is-equilateral and is-right. So that triangle program is under Presentation Materials for Chapter 5. Please create a hierarchy chart for that with draw.io. You don't have to submit it, but please create one. And when you're done, hit resume. Okay, did you get it? Gosh, I hope so. Here's how I solved that one. And here's my solution. Okay, done in draw.io. Remember that in the triangles program, and let me just move this out of the way here, our first call is the main, and then main calls print. So, oh, and I guess I don't really have my call to print, but I could. Okay, main calls print, and then, oh, excuse me, no, main does not, yep, main calls print, and then it calls the input function, right, to get a value, and it calls the int function. So main calls int, which calls input, and that's how we have that reflected here. And so on for each of those. So it gets the values using int and input, it prints out a message, it calls is-equilateral, and notice that is-equilateral also calls print, is-right also calls print. Why does it call it twice? Is that correct? Nope, we should only have one in there. That is a mistake. So let's take that out. And there we go. So the purpose of a hierarchy chart is to give you an overall picture of what functions are called and in what order they're called. Moving on. Local variables. Now, a local variable that is a value that, or excuse me, a variable that's assigned a value inside of a function. And that variable can only be used inside of that function. That is, it belongs to the function in which it's created. Only statements in that function can access it, and you'll get an error if another function tries to access it. This is part of a bigger concept called scope, in which part of the program, a variable, may be accessed. For local variables, they can only be accessed in the function that created it. It can't be accessed by statements that precede its declaration. And different functions may have the same name, local variables. Okay, so you could use those twice. Let's see two examples here. Let's look at this one. Let's look at birds first. Okay, so birds, we have a main function that calls two other functions, California and Texas. Okay, in Texas, notice we have a variable called birds that we set to 5,000, and then we print out however many birds that Texas has. Texas has whatever birds is birds. California sets birds to 8,000. It prints out California has birds, birds. So I'll put a breakpoint here. I'll hit debug. I'll step. So we call Texas. We assign birds 5,000. So if I mouse over birds, you see it's 5,000. And then I output, you can see that down at the bottom here. Texas has 5,000 birds. Then I call California. California has a different variable called birds, okay, because it's inside of California. And I step, and it prints out California has 8,000 birds. Now, if I tried to do something like this, you know, print there are birds like this, I'm going to get an error message. Here, let me show you this. I'll just try to run it. And the reason is because birds in both cases is local to that function. Okay, it can't be seen outside of Texas. This birds can't be seen outside of Texas. And this birds can't be seen outside of California. I get an error if I try to access it. Similarly, if I did this in the wrong order, if I tried to access birds before I assign it a value, before I declare it and assign it a value, watch what happens. So I get an error message, and the error message says local variable birds has not referenced before assignment. So you've got to assign, you've got to create a variable, assign it a value before you can use it in Python. Let's look at one more called bad local. Okay, so we have our main function that calls getName, and getName just asks for your name and puts it in a variable called name, and then back in main it says hello name. Okay, and notice the comment says this causes an error. So if I run this program, it says ask for your name. I'll say Charles, and notice it says name is not defined. Why? Because name is declared inside of getName, so it's not accessible outside of getName. It's only visible. It's only in scope inside of getName. So one more exercise. I want you to write a program that has 3 functions. Okay, one called Iowa that asks for the number of voters in Iowa and prints the number of voters in thousands. One called Illinois, which asks for the number of voters and prints the number of voters in millions. Okay, so Iowa prints in thousands, Illinois prints in millions, and Maine, which calls Iowa and Illinois. So pause the presentation here, and when you're done, come back. Okay, did you get it? Gosh, I hope so. Here's how I solved it. So here's my title block at the top with my file name, my last revised date. Actually, that's not the truth. Just made a change. And the description of what the program does. So here's my Iowa function, where I prompt the user for the population of Iowa. And to print out the value in thousands, I take whatever that number is, divide it by 1,000, print it out, and it gives me that result. In Illinois, I ask for the population of Illinois, and because I want the population in millions, I divide it by 1 million. So let's walk through this program. We'll put a breakpoint here. We'll hit debug. So we'll print welcome to my program, and we'll just go ahead and step over that. We'll call the Iowa function, okay, and it'll ask for what's the population of Iowa, and I believe it's 3.3 million, so I'll say 3,300,000, and I'll click on OK, and I'll say the population of Iowa is, we're watching the bottom, 3,300,000, right? It's because there's 1,000 in a million. Then next I call the Illinois function, and let's see here. Oh, things are locking up on us here. Is anything happening? No, PyScripter decided to quit on us. Okay.